Hey everybody, Mike here with another GIS tutorial. Today, I want to share a project where I used arcpy to iterate through and clip several features. Now, in this project, I was working with a data set of polygon features representing the different prefectures in Greece, and then I was working with a second data set that represented the road network in Greece. And since the data sets were large, it was going to take a lot of time to manually select each polygon and clip the features that way. So instead of doing it manually, I used Jupyter Notebooks in ArcGIS Pro and arcpy to iterate through those features, as you can see in the visual on the left. And so without further ado, let's dive into it. So I've hopped on over to ArcGIS Pro and I've got my data visualized in the map. Before I get into the Jupyter Notebooks portion of the tutorial, I want to take a look at the polygon attribute table to find some information that's going to be useful to us when we start writing our script. To do so, I will go over to the Contents window, right-click the Greek prefecture boundaries, and open the attribute table. Now, I'm looking for a field to iterate over and also a way to name my files with something relevant to the data set. So the two columns I want to point out are the FID column here, which is what we'll use to iterate through. So it'll iterate through each FID, find that polygon, just like it's doing on the map right now. And then I'm going to name my files based on this name English column. And we're going to have to do something a little special with that once we get there. So just keep that in mind, the FID column and the name English column. So I'll close that, and then I will open up my Jupyter Notebooks. I already have one prepared, but if you haven't done so before and need to open your own new Jupyter Notebook, make sure to come to the Insert menu option, find this new notebook, and click New Notebook. And it'll open up a new notebook for you. I'm going to hop over to the tutorial one that I already have prepared, close this one. But here's our Jupyter Notebook. So we're going to have it organized into 3 sections. We're going to import some packages, define variables. We're going to select and clip the features, and then I'll share the links to some information that you can reference to do this project on your own. So let me go ahead and expand those back out. So the first thing we need to do is import our packages, which in this instance, we will import OS so that we can do save files. And then we'll import arcpy so that we can use the search cursor and clip function and the select layer by attribute function. So I will hold shift and then press enter to run that cell. It went through successfully. And then the next thing that I'm going to do is define my environment variables. Now, I've left these empty so I can show you a quick way to hop over to the catalog window and copy and paste the file path over. I have my files in this shapefiles folder. I'll left click to expand that, and then I'll hover over the shapefile I'm interested in, right click it, and then copy path. I'll come over, that's my boundaries. So I want my boundaries to be in the poly variable. I'll right click and hit paste. And I'll add some quotations around it. And also put double backslashes, because Python can get confused with a single backslash. So I'll just repeat that for the Greek roads. Right click, copy path. That'll be in my roads variable. And add the quotations. Add a double backslash. And I also need to pick an output folder. Here I have prepared an output folder that is empty, but I'll go ahead and right click it and copy the path. Paste that in there, and this time I'm going to change all of the single backslashes to forward slashes. You'll be pretty safe when you're defining file paths to either use double backslashes or a forward slash for Python to recognize the file path appropriately. And then the last thing I'm going to do here is create a list variable called polyfilled that's going to reference that FID column and the name English column that I pointed out before. So I will hold shift and press enter to run that cell, and it ran successfully. So the next thing we'll do is write an arcpy search cursor function to select each individual polygon, iterate through it, and clip the road features. To do that, the first thing we'll need to do is write an arcpy search cursor statement, and then we'll write a for loop within the search cursor statement to iterate through each FID in the data set. What I'll do to know how to write the syntax is I'll go to the web page. So you can Google, ArcGIS Pro search cursor or arcpy search cursor. I already have the link here, so I'll just copy it, jump to Google, and paste that. On the web page, you can read the summary of the tool. You can look at the syntax. So for search cursor, we have our in table and our field names, which are required parameters, and then like a where clause, spatial reference as optional parameters in case we need them. And then usually below this information, there will be examples in the code. So I'll scroll down to one of those examples and see how the search cursor statement has been written here. With arcpy.da.search cursor, feature class and fields as cursor, for row and cursor. So I'll jump back to ArcGIS Pro, and I've written that for my feature class. I'm using my polygon features, the Greek prefectural boundaries, and then for the fields that I want to participate in this search cursor, I'll use the FID and name English columns pointed out earlier. Then I'll write for FID in cursor. So I'll know that I'm going to iterate through each FID. In order to do that, it's necessary to tell the script that you want to perform a new selection on the polygon features by the FID. So we'll need to use the arcpy.selectLayerByAttribute arc function. Now, just like before, I'll do some research on the internet to figure out my syntax, kind of what that function does. So I'll copy and paste this link. And we'll see that the select layer by attribute tool will add, update, or remove a selection based on an attribute query. If I scroll down to the syntax, we'll need to give it a layer to work with, And then optionally, we can give it a selection type and a where clause. And I do want to give it a selection type. So I can scroll down to the selection type reference table, and I want to perform a new selection. And then I also want to write a SQL expression. I'll scroll down to one of the examples, and you'll see in this code sample, they've referenced a states layer, and they want to perform a new selection on it where the name column equals California. Going back to our script, we want to reference the polygon features, and then we want to perform a new selection on the FID. Now, this particular SQL query that I have highlighted right now, I'll admit I've had a little bit of trouble getting a query here to work, and I believe I found this reference on like Stack Exchange or something. So it works. If you have another way that you know how to do it, let me know. And we'll write that function, but we want to be able to use the feature that it's referencing in the next step, which is to perform the clip function. So I'll go ahead and make a variable called feature. And every time this for loop happens, it'll define a new feature based on this select layer by attribute function that we've written. And now that we have that in place, we'll write a clip function, which will use arcpy.analysis.clip. I'll go ahead and copy and paste that and take a look at it. And it'll extract input features that overlay the clip features. You've kind of already seen the example in the intro of the video, and here's the Esri's illustration. And got our syntax here. We want to include our input features, which will be our roads, our clip features, which will be our polygons, and then we'll need to tell the script where to create the output files. And here's a brief code example. We've referenced the shapefile here of roads, referenced the shapefile of polygons, and then defined a output. So jumping back into our Jupyter notebooks, I'll go ahead and define these variables within the script. So for my in features, I'll equal it to roads. And since I've defined a variable up here in a previous block, it will put this file path into that variable when it runs. For my clip features, I'll run feature, and as I just discussed, each time this for loop happens, it will select a new polygon with this feature variable. That polygon will be what's input into our clip features. And finally, we need to tell the clip function where to put our output files. So in this out feature class variable, I'll let it know to put it in the output location, which we've defined in this previous code block. And then I'll also tell it how to name our shapefile each time that it runs. And so it's a little tricky what I have written here, but I'll try to explain it. So when the tool runs, it'll put the file in the output location, and then it'll name the file based on what I tell it to put here in these curly brackets. And then it'll add _roads.shape to the name afterwards. And I'll show that after the tools run. Each time it runs, it will reference the one index that our FID parameter our fid variable in the for loop is referencing. Now our fid is referencing the polyfilled variable that we have defined earlier. So the fid column is the 0 index, and the name underscore English is the 1 index. So this will actually be referencing the 1 index of the name English. So for example, here we'll use name English from the polyfilled variable to name the file. But then the second part will tell us from that name English column, we want to name the file starting at the 3rd index. So that'll be our 4th character. We got our 0, 1, 2, and 3 index. And for example, when I looked in the table at our data, if I go back to that, we'll notice in this name English column that all the names unanimously, they start with this n dot and then space. Now, dots and spaces are generally bad for file names when it comes to writing scripts and such. And so I just want to eliminate those entirely. So I'm going to start at the 4th character, which for this one, it would be Paerius, or in this one, it would be Pelis. And apologies if I'm mispronouncing the Greek names. So that's what's happening here. So I'll go ahead and run this, and it's going to take a while. So I'll cut the video to after it's done running and show you what our files look like and what our outputs look like. All right, so jumping about 10 minutes into the future, our tool is finished running and we have some results to look at. You can see that the contents window over here is pretty full. And let me also go ahead in the catalog window, expand our outputs folder. And you'll see we have a bunch of shape files that were output. And with the naming scheme, the Greek prefecture underscore roads.shape that we're able to do with this bit of syntax right here. Let's jump over to the map and clear that selection. But you can see that now, instead of having just one set of roads, like we started with, there it is. Now we have a bunch of roads. And then one thing with this, let me go ahead and minimize some of this stuff. The road layers are permanent layers. So when we ran the tool, we have an output location that they're permanently saved to in memory. The polygon layers, however, all of these are temporary layers. So if I go to our database we're working in and refresh it and look in our outputs folder, and we'll see like the polygon boundaries aren't saved anywhere in memory. They're temporary layers. If I save this project and I close it and then I reopen it, the roads will still be there, but all of the polygon layers will be gone. And I'll just go ahead and remove all of those from. Let's go through and click some of our data. Let me zoom in to the part of Greece that I had in the example visualization at the beginning of the video. And you'll see that we have road features just for this polygon here, and then road features just for the polygon there. So we've accomplished our goal, and I was able to do it save myself some time by writing a quick script and instead of having to do it manually. And one thing that's great about something like this is once you have the script in place, it's scalable to new data sets. All you really need to do is change the file path, change the input variables here, and then adjust the columns that you're going to work with accordingly. And if you have 100 or 1,000 or even more records to deal with, it takes a few moments to adjust the script, but it takes a whole lot longer to do it manually. So I hope you enjoyed the tutorial. I had a lot of fun doing the project, and let me know if you have any suggestions. I hope you learned something. Like and subscribe, and stick around for some more geospatial stuff. See ya.